Hi everyone, so my name is Gretchen Johnson, and today I wanted to do a brief 5-minute whiteboard presentation, just giving an overview of the mitochondrial genome and the proteins that are encoded in this and used in the mitochondria. So up here, I'm going to put some objectives of what I want to discuss. So I'm going to tell you information about the mitochondrial genome. I want to tell you about the proteins that are encoded by this. I also want to tell you about proteins for the mitochondria that are encoded in your nuclear DNA. And then I also want to tell you how those proteins are directed to the mitochondria. So with that in mind, what most people know about the mitochondria is that it's this double-membraned organelle that is responsible for creating energy. So its main output is the creation of ATP. So what some people don't know is that within your mitochondria, you have mitochondrial DNA, which I'm just going to label MtDNA because that is what it is commonly referred to as in the shorthand. So just some facts about the mitochondrial DNA to be aware of. It is, as you can see, circular and double-stranded. It is maternally inherited, so you get it only from your mom and not your father. It is about 16,000 base pairs long, so much smaller than your nuclear genome, which is around 3 billion base pairs long. And it has a high copy number. So you only have 2 copies of your nuclear DNA, but you actually have anywhere from 100 to 1,000 copies per mitochondria. So then you have multiple mitochondria in your cell. And so this can give different cell types many different numbers of mitochondrial genome based on its energy needs. And then the genome only has 37 genes, 22 of which code for transfer RNA, 2 are for ribosomal RNA, and then the remaining 13 genes are for proteins. So these proteins that it makes up, or that it encodes for, actually only form 4 complexes or 4 major proteins. So that is ATP synthase, cytochrome C oxidase, cytochrome B, and NADH dehydrogenase. Obviously, there are going to be a lot more proteins within the mitochondria, both related to energy production and its other functions. And so how did the rest of these get into the mitochondria is what we're about to discuss. So over here you have your mitochondria, and we'll put your nucleus over here. Okay, so within the nucleus, this is where, your DNA that undergoes transcription into RNA, and this occurs within the nucleus. Then the RNA is sent out to the cell, or into the cytoplasm, where it is turned into proteins through translation. So for the proteins that are being directed to the mitochondria, it actually encodes mRNAs, so just little messenger RNAs that are codes that will recognize its corresponding protein and kind of bind to it to kind of direct it and be like, okay, we need to go over to the mitochondria. So once it is directed by its mRNA to the mitochondria, it interacts with Tom and Tim. What Tom and Tim stand for is translocase of the outer membrane and translocase of the inner membrane. So some of these proteins can interact with the translocase of the outer membrane and be directly integrated into the membrane of the mitochondria. And then other proteins that are destined for the matrix or the inside of the mitochondria will interact with both Tom and then Tim. because it has to cross through both to get in there. So that is kind of just how proteins that are encoded in here match up to their corresponding tag almost, and then tag is what will bring it to the mitochondria for integration. I also wanted to note that there are about 1,500 proteins that are encoded by the nucleus destined for the mitochondria. So there are a ton, and that's why I'm not going to really list any here. So just with all that in mind, I wanted to just review what we covered. So I discussed the mitochondrial genome. I discussed mitochondrial encoded proteins, nuclear encoded mitochondrial proteins, and then how these are directed to the mitochondria. Some applications of this knowledge that I just wanted to go over to emphasize why I was talking about this. So knowledge about the mitochondrial genome is important in forensics because it can be used to identify family like linkages. It can be used for studies on evolution because in theory it doesn't undergo changes because it's just passed from your mother to the offspring, but over time it will naturally change and there will be some mutations that would cause it to change. And so this can be tracked for evolutionary purposes because it doesn't change as much as your individual nucleus DNA will change. Another degeneration, spelling is hard. Another aspect of researching mitochondrial genome is aging and neurodegeneration studies. So because the mitochondrial genome is important for energy, which is used in pretty much everything that your body does, in aging and neurodegeneration, there's been implications that dysfunction of your mitochondrial genome is what is causing these declines. So it is still being researched heavily, but that is something that is of interest specifically to me, since I'm wanting to stay in neurodegeneration and aging studies, but with a focus on the mitochondria. Just some other field, it can be used in cancer research, and then as well as just there are mitochondrial diseases. So that's just an overview, just briefly, of how those work and how it can be applied. So thank you for your time.